Good afternoon, students. Everyone sit straight now. Yes. So can you all tell me what is this glass object called as? Glass slab. Yes. Generally, how does the light travel? In a straight line. How does the light travel through the glass slab? It slightly bends from the path of the light. Yes. Now what is that phenomenon called as? Refraction. Okay. So we have already learned about this. Yes. So can someone define what is refraction? Anyone? Yes. Get it.
The bending of light passes through one transparent medium to another is called refraction.
Very good. When a light travels from one medium to the other medium, the bending in the light is called as refraction. Yes. So you all remember? No, you can recall whatever we have learned in refraction of light. Yes. So now I just will all do a small exercise now. Yes. You all can see it's large here. Yes. Now what is the first word given here? Incident ray. Which is the incident ray here? Can we match it in the correct box? Which is the incident ray? Yes. This is your incident ray. What is the next word? Angle of refraction. So which is going to be your angle of refraction? Bottom one.
Excellent.
Yes. What is the next word?
Angle of incidence.
Angle of incidence is here.
Excellent.
And what is the next word?
Normal.
Normal. Where we have the normal?
Excellent.
Yes. So we have the incident ray. Yes. What is the angle? What is this green line? Normal. So what is the angle between the incident ray and the normal? Angle of incidence. So when a light travels from rarer medium to denser medium, it bends towards the normal or away from the normal? Towards the normal. So what is this ray called? Refracted ray. Okay. So this angle here is your angle of refraction. Now what happens to the light when it travels from denser medium to the rarer medium? Very good. It bends away from the normal. So what is that ray called? Emergent ray. So what is the angle between the normal and the emergent ray? Angle of refraction. Okay. Very good. Now tell me what is this object called as? Prism. Okay. Now tell me how many triangular base we have? Triangular surface we have? Two triangular surface. How many rectangular surface we have? Three rectangular surface. Okay. So a prism is two triangular base and three rectangular lateral surfaces inclined together is your prism. Okay. So when two rectangular surfaces incline to each other, an angle is formed. What is that angle called as? It is called angle of prism. Clear? Yes. Now how does the light travel through a prism? Have you ever wondered about that? Okay. So can you all see this ray of light here? Yes. You can see it is traveling in a straight line. Okay. So once it is incident on the surface of the glass, so can you all see the bending of the light? Yes. Can you all see the change? Okay. So now we are going to trace the path of the light when it travels through the prism. Clear? So now everyone take your classwork. Write today's date. Write the topic refraction through prism.
Different.
So we are going to start with refraction through prism. So you all know refraction means bending of light when light travels from rarer medium to the denser medium. Yes. Now when a light is incident on a prism, when a white torch light is incident on the prism, we trace the path of the light now. Okay. So this is your prism. Yes. A light beam of light is incident on the lateral surface of the prism. Now what is this ray called? Incident Now be ready with your pencil, scale, protractor. First, in the center of your page, draw a line of 5 centimeter. Okay, so one second, everyone look here. First, draw a line of 5 centimeter. Take your protractor, keep it at point B. Okay, mark 60 degree and draw a line of again 5 centimeter. Keep it at point C. Again draw, mark 60 degree and draw angle. Okay, so you are going to draw this triangular base there. Have you all drawn it? Use a scale and draw. That is very important. Now name your triangle as A, B, C. Have you all named it? Now we are going to draw the incident ray. Okay? Draw the incident ray. PQ will be your incident ray. How many of you have drawn? Yes, good. Now we are going to draw a normal at point Q. Okay? At point Q, keep your protractor, mark 90 degree and draw the normal. Good. Now next step, everyone look here. Now what happens to the incident ray? It gets refracted. Now we are going to draw the refracted ray. Next step. Draw the refracted ray. And one more thing, while drawing the ray of light, okay, the arrows is very important. So the direction of arrow is very important. Make sure you mention the arrow there. Next step, at point R, we are going to mark a normal. Draw a normal at point R. Make sure it is a dotted line. Label your both the normals. M dash, M dash. Have you named it? Yes. Now we are going to measure your angle of incidence. Okay. Take your protractor. This is your angle of incidence. Yes. So measure your angle of incidence and draw it. Okay. Draw the emergent ray now. Draw the normal. Draw the emergent ray now. how many of you have completed? Raise your hand. Finish drawing it fast. Okay, shall I give a small test now? We all do it together? Yes? Now tell me, what is the first word here? Emergent ray. Where do you think the emergent ray is? Here? Okay, so this is here, emergent ray. What is the next word? Angle of incidence. Angle of incidence. Where it is?
Try again.
Yes, the angle between the normal
Excellent.
and the incident ray is angle of incidence. What is the next word? Incident. The incident ray. So we all know where it is. Yes.
Excellent.
What is the next word? Normal. Where is normal? Here? Yes, it is
Excellent.
the dotted line. What is the next word? Angle of emergence. Okay.
Excellent.
So you're all clear with how to trace a path of light through the prism. Yes? So we'll answer a few more questions for now. Refraction occurs when the light passes through the boundaries of two media. Yes? Check whether the answer is correct. When a ray of light is refracted through a triangular prism, it is seen that the emergent ray bends at an angle to the direction of the incident ray. This angle is called as angle of emergence. What is the correct answer? How many of you say angle of emergence? Angle of deviation. Next, the angle between two lateral surfaces of a prism is called angle of prism. Very good. A prism has dash triangular surfaces and dash rectangular surfaces. Okay, so now we are going to see something very interesting now. Okay, so tell me, how many of you have seen rainbow? You all have seen rainbow. Where do you see the rainbow? In the sky. How many colors does the rainbow have? 7 colors. What are all the 7 colors? Okay, what is that synonym called as? Vijaya, right? What does V stands for? Violet. Okay, violet. Then blue. G stands for green. Yellow. Orange. Red. Right? These are the 7 colors what we see in the rainbow. Yes? When do you see this rainbow? After the rain shower. Yes? In which direction do you see? Opposite side of the sun. Okay? So we learn about all these interesting things. Okay? So now talking about, let me show you this one. What happens? What is this called? Prism. Okay. It is a monochromatic light. Okay, monochromatic. What color beam of light is this? Red. Okay, we can change the color of the light also. Okay. So when a red light passes through the prism, what is this phenomenon called? Refraction of light. Okay. Now what happens when a white light passes through the prism? Okay, we'll see that. Can you all see a white light passing through the prism? What you all can observe here? Colors. A white light splitting into different colors. Yes. So what is that called as? It is called dispersion of light. Okay. Splitting of white light through the prism is called dispersion of light. Okay. Now what is this band of colors here called? Spectrum. Okay. Band of the constituent through a prism is called dispersion, and this band of light, okay, band of constituent colors, what we obtain here basically is called spectrum. Clear? Okay. So now Newton was the first scientist who got the spectrum when he used the prism the sunlight. Okay. So now he was very inquisitive and he was trying to do experimenting more. Okay. So what he did, he took one more prism. He tried to keep it in different angles here. Okay. He tried to keep, hoping that he will get much more colors than 7 colors. He thought of getting much more colors. Then at some angle here, he was trying. He kept it inverted here like this. Okay. In the inverted position here, at that time what happened? I'll make sure it is. Yes. So now what happened? White light, okay, was traveling through the prism. We got the spectrum here. The spectrum then again was incident through the prism and came out again as a white light. Okay, so we learn all about the video now. Yes?
Have you ever wondered why you see a rainbow in the sky just after a rain? Where do these vibrant colors come from? Well, this can be explained by the phenomenon of dispersion of light.
Where do these colors come from? Phenomenon is called dispersion of light. But how does a rainbow get all these colors from? Okay, we'll learn about it.
Let's see how we can create this rainbow ourselves. You will require a white light torch, a cardboard with a pinhole, and a glass prism. In a closed room, place the cardboard between the torch and the prism on a table, draw the curtains and switch off the lights to darken the room. Switch on the torch. A narrow beam of light passes through the hole and falls on the glass prism. Amazing, isn't it?
Yes. So what is this band of colors here called? Spectrum.
Newton was the first one to realize that a wide ray of light, such as sunlight, is composed of different colors. When white light enters the prism, it gets refracted, producing 7 different rays of colors.
But why do you think a white light is dispersed like this? Why you can't get it as a white light only? Where do we get all these lights from? Different colors here. We have red color, blue color, green color. All different colors travel it bends at different angle. Okay, now tell me, comparing the violet light and red light. Okay, which one do you think bends more? Violet light here bends more. Yes, which bends less? Red light. Okay, so now this is according to the wavelength of the light. Okay, so red color has high wavelength. Okay, violet color light has less wavelength. Clear to you all? Now which one travels faster? Red light travels faster and violet light travels slower. Yes?
The angle of refraction is different for each color. Thus, each color bends to a different angle with respect to the incident ray and the color split up. Separation of a beam of light into its constituent colors is known as dispersion of light.
What is dispersion? We will say it together. Separation of dispersion. Yes? So you can note it down in your classwork now. What is dispersion of light? Separation of a beam of light into its constituent colors is known as dispersion of light. Written?
And the band of colors is known as a spectrum.
What is the band of colors called as? Spectrum. Yes?
Now that you know how light splits up into different colors, let's find out how a rainbow is created. A rainbow is formed in the sky with the help of two things.
Okay, so before that, we try to draw how Newton got the spectrum of light. Yes, we try to draw that. Now take a fresh page now. Write the topic: recombination of spectrum of white light. You all have got your red pen and violet pen? Yes? Now draw a triangle, mark it as A, B, C. Now draw one more triangle in the inverted position. Name the triangle as PQR. Now we are going to draw the incident ray at side AB. Make sure you put the arrow there. This is the special property of dispersion, okay? It happens only in the prism and only white light is incident on the refractive surface. Okay, we don't get dispersed light spectrum in a rectangular glass slab. Okay? Have you drawn the incident ray? Now take your red pen and violet pen. Draw the normal now. Draw the red light. Which light travels faster? Red. Which one travels slower? Violet. Which has high wavelength? Red. Which has lower wavelength? Violet. Yes. You have drawn the arrow also? Yes. Next step. Draw the normal there. Now we are going to draw the emergent ray. Make sure you put the arrows here. We are drawn it. Yes. Shall we move on to the next step now? of the raindrop. Now what happens? Dispersion happens. Yes? Red light travels faster or slower? Yes? So this is the direction of the light. Okay. Now what happens? It gets refracted first. Yes. Now internal reflection happens. Okay. So what happens to the violet light here? Here. Red light. And again one more reflection happens. Okay. So red light comes. So you are clear how is a rainbow formed? Yes. So this will be your spectrum. What you can see as a rainbow in the sky. Yes. So you see that video there. So you will be much more clear about how is a rainbow formed.
Thus, the angle of refraction is different for each color. Thus, each color bends to a different angle with respect to the incident ray and the color split up. Separation of a beam of light into its constituent colors is known as dispersion of light, and the band of colors is known as a spectrum. Now that you know how light splits up into different colors, let's find out how a rainbow is created. A rainbow is formed in the sky with the help of two things: the sun and water droplets. These water droplets could be in the form of rain, cloud, or mist. Sunlight bends as it enters the droplets in the air. The droplets reflect off the sunlight internally and refract the light again.
Here we are. How this first dispersion occurs? Yes. First refraction, then internal reflection, and it comes out as rainbow forms.
As it moves out into the air. In this way, each water droplet acts as a prism and disperses sunlight. Together, millions of such tiny droplets form the boat-shaped spectrum in the sky.
You usually told always rainbow will be formed in the opposite direction of sun. Okay.
The acronym VINCURE is used to remember the sequence of the colors in a white beam of light. From the spectrum you can see that red color bends the least and violet color bends the most. Now, let us go back to our prism and torch setup. What will happen if we place another prism in front of the emerging spectrum? Did you see that you got back the original beam of white light?
Yes. The combination of the dispersed light as again as a white light.
What if you mix these 7 colors together? Do you think you would get white light? The colors of the visible light spectrum when combined form white light. Let us prove this by doing a simple activity. Take a paper disc and draw 7 sectors on it. Color E.
Now this will be your weaker assignment. Okay. So make sure you listen carefully.
Each sector sequentially with the colors of the visible spectrum. Now, spin the disc. The disc will appear white in color. Remember that the disc just appears to be white. It does not really reflect back white light.
Here we are. Yes. So in today's class, whatever we actually will recall all the points now. prism. Okay. Now we learned about what is angle of deviation. Yes, what is angle of deviation? The angle between the incident ray and the emergent ray is called the angle of deviation. Okay. Then we learned about what is dispersion. Okay. The splitting of white light into its constituent colors is called dispersion. Okay. So what are the seven various colors we have? With GR. D stands for
Violet, indigo, blue, green, yellow, orange, red.
yes. So what is the band of colors called as? Spectrum. Very good. Okay. So now tell me, red light has high wavelength or less wavelength? High wavelength. Okay. It travels fast or slow? Faster compared to the violet light. Okay. So according to the wavelength of light, different colors travel at different speed. Now talking about the recombination of the spectrum of white light, who actually tried all this experiment? Newton. Very good. Okay. So white light can be any white light. Okay. Any light where you can get a spectrum. Okay. That is considered as white light. Clear here? Yes. So white light that can be dispersed into 7 constituent colors is called dispersion. Okay. So now, so using that experiment, okay, what actually Newton concluded? Sunlight has 7 colors. Yes. Then how is the rainbow formed? Yes. In which direction is the rainbow formed? Opposite direction. Okay. You could have even seen that sometimes if you are playing in a waterfall and the sun is behind you, that time also you can see a rainbow being formed. Okay. The water droplets, small water droplets acts as a small prism. Okay. So now we are clear about all these things. We'll have a small test now. Read out the question. Which of the following represents the 7 colors of the white light spectrum? Tell me which option, A, B, C or D? D? B. Very good. Second question. Which of the following natural phenomena show dispersion of light? Which option? Rainbow is correct. Very good. Through which of the following objects can we observe dispersion of light? Glass prisms. Yes, we can't observe dispersion of light in a glass lab. Okay. Next question. Which of the following disperses the light of the sun to form a rainbow? Film of thin air, water droplets of rain. The splitting of light into its component colors by a prism is called dispersion. Dispersion of light is which of the following words acts as an acronym? Spectrum. Which option you tell me? Okay, so very good. So you're all clear about